guys, welcome back to my YouTube channel. Today I'm going to solve day 13th problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I'm going to solve problem number 2751, robot collisions. Okay, so this is marked hard by LeetCode, but in reality I'm going to say that this problem is going to be of medium level. Okay, so now let's read the problem statement. Okay, so there are n1 indexed robots, each having a position on a line, health and movement direction. Okay, so we are given with the 0 indexed integer arrays, position, health and string directions. Okay, and directions I is either L for left or R for right, and all integers in positions are unique. Okay, all robots start moving on the line simultaneously at the same speed in their given directions. If two robots ever share the same position while moving, they will collide. Okay, so if two robots collide, the robot with lower health is removed from the line and the health of other robot decreases by 1. Okay, the surviving robot continues in the same direction it was going. If both robots have the same health, they are both removed from the line. Okay, so these lines are important. Okay, so your task is to determine the health of the robots that survive the collisions in the same order that the robots were given. Okay, so final health of robot 1 if survived, final health of robot 2 if survived, and so on. Okay, so we have to maintain the order in the end, okay, of their health. So if there are no survivors, then we have to return an empty array. Okay, so we have to return an array containing the health of remaining robots in the order they were given in the input after no further collisions can occur, and the positions may be unsorted. Okay, these are the constants given to us. Okay, so size is very large, from 1 to 10 raised to power 5. Okay, and position and health array values are also from 1 to 10 raised to power n, and two type of directions are given to us, L and R. So here the ASCII values of the characters L and R are 76 and 82. Okay, so we are going to use these two in our code, so that is why I have written here. So ASCII value of L is 76 and ASCII value of R is 82, and all values in positions are distinct. Okay, so now let's understand this problem with an example here. Okay, so first see position. This is my positions array, right? 3 5 2 6. Okay, so here let me write it like this: 3 5 and 2 and then 6. Okay, so here what I'm going to do, this 3 simply means my robot number 1, this 5 simply means my robot number 2, position of my robot 2, this 2 simply means the position of my robot 3, this 6 simply means position of my robot 4. Okay, so now I'm going to create one positions array. Okay, position type array. So this is my first position, this is my second position, this is my third position, this is my fourth position, this is my fifth position, and this is my sixth position. Okay, so see, this robot 1 is placed on third position, right? So here I'm going to place my robot 1. Okay, robot 1, and robot 2 is placed on position 5. So here I'm going to place my robot 2, and the robot 3 is placed on position 2. So here I am going to place my robot 3, and robot 4 is placed on position 6. So here I am going to place my robot 4. Okay, this is done. Then after that, these directions are given to us. R is direction for robot 1, L is direction for robot 2, R is direction for robot 3, L is direction for robot 4. Okay, so for 1, this is robot number 1, direction is R. Okay, direction is R for robot 1. Okay, robot 2 direction is left, so this is my robot 2, right? Direction is left. Robot 3 direction is R, so here for robot 3 direction is R. Robot 4 direction is left. Okay, for 4 direction is left. Okay, so see, this diagram is matching now, right? So 3 1 2 4, 3 1 2 4, right? And these are the positions, and right right, these two are left left, right right, left left. Okay, and here health, this is health for robot 1, this is health for robot 2, this is health for robot 3, and this is health for robot 4. Okay, so let's write it. For 1 is 10, for 2 is 10, this is my robot 2, 10, and for 3 it is 15, so here I am writing 15, and for 4 it is 12. So see here, 15 10 10 12, 15 10 10 12. Okay, so now I hope that you guys clear it with this diagram. Okay, so now after that, see, this robot is moving in this direction, and this robot is moving in this direction. Okay, so in between there is position 4, and both the robots will collide at this particular position, right? Since both the robots have same energy, so I am going to remove both these robots. Okay, so see here, this is given here, both robots have the same health, they are both removed from the line. Okay, so I have removed both the robots. Okay, now after that, definitely these two robots are going to collide, because this is moving to the left direction and right direction, and this is going to move toward the left direction, right? So they will collide. So which robot has higher energy? This has higher energy, this has less energy. So I am going to remove this, and this has higher energy, no? So 15 is the higher energy, right? So I am going to subtract 1. 15 minus 1 is equal to 14 after collision, right? So 14 is going to be my output. Okay. Robot with lower health is removed from the line, and the health of other robot decreases by 1. Okay, that's it. So I hope that you guys are clear with the explanation. So in this example 1, if you make the diagram just like this example number 2, okay, I have explained the example number 2. Okay, so if you make the diagram for example 1 using this input, okay, so you are going to see that all the robots are moving in the same direction, so they will never collide. Okay, so I am going to directly write that their healths, okay, and we have to maintain the order like 2, 17, 9, 15, 10, then this order is maintained. Okay, so see here, your task is to determine the health of robots that survive the collision in the same order that the robots were given. Okay, so we have to maintain the order. Okay, this is one more thing. Okay, so here first thing that I am going to do here, I am going to sort the robots based on their positions, right? So first I am going to place the robots based on their positions. Okay, so first this robot will come, right? Then this robot will come, then this robot will come, then this robot will come. Okay, so first I'm going to write 2 position, then 3 position. Okay, so what I'm going to do, I'm going to do a sorting, but before sorting I have to create one merged array. Okay, so my positions are like this: 3, 5, 2, 6, and my healths are like this: 10, 10, 15, 12, 10, 10, 15, 12, and my directions are like this: RL, 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 RL. Okay, so now I have to sort. So first this will come now. So first this will come 215R. So first 215 and R is coming, right? Then this will come. What is this? 310R. Okay, so 310 and moving directions R. Okay, then after that this will come, right? 510L. So see, 510 and moving to the left. Then this will come 612L. 612 and L. Okay, so I have to create one merged array, and I have to sort the merged array then. Okay, based on their positions. Okay, and also I'm going to store their original index. Okay, so this is original index is 1, original index is 2, original index is 3, original index is 4. Okay, number 4. Okay, so I have to store the I have to write the original index side by side. Why I am writing this original index? So that in the end I maintain the order of their health, okay, of the survived robots. Okay, so now let's move to the coding part. So in coding you guys will get more clear idea. Okay, code is going to be very simple. I don't know why LeetCode marked this problem as hard, but this is medium according to me. Okay, so now first let's create one variable int n positions dot length, and then create one 2D merged array. So let's name it as merged. N is going to be size. I'm storing positions, I'm going to store health, and I'm going to store the directions. Size here I'm going to give is 4. Okay, because I have to store this 0, 1 and 2 now, right? And also I'm going to store the my indexes. Okay, that is why I'm going to write 4 here. Okay, so now after that let's run one loop. Let's add the value in merged I of 0. Okay, in merged I of 0 I have to add positions of 0, positions of I. Okay, and then same way we have to store the values right here. Here is merged of I of 1. Okay, first row, first column, and in first column I'm going to store healths, and in the first row, this 2 index column, I'm going to store directions. Okay, since directions is a string now, so I have to write it like this: directions dot char at this index. Okay, and then I have to store the original index as well now. So let's store it here, merged of I of 3. Okay, so here I'm going to just store the original index. Okay, that's it. So how I'm writing here? So this is my this is how it looks like, right? So I'm creating my merged array. So in the first row I'm writing position, then I'm writing health, then I am writing direction, and then I am storing the index. Okay, so this is the order that I am writing. Okay, row 0, column 0, column 1, column 2, column 3. Okay, so this is done, right? Now after this we have to sort the array. Okay, arrays dot sort. Okay, so here which array I'm going to sort? Merged array. And let's take two parameters, a and b. Then I have to sort this in increasing order, right? So I'm going to use lambda expression. So here a of 0 minus, based on their position I'm sorting, so here that is why I'm writing a of 0, b of 0. Okay, this is done. I have sorted the array. Then I have to simulate the collisions. I'm using stack only, so you can, instead of dq, you can write here stack as well, no issues, your code will run, but dq is much faster. Okay, array dq is much faster. New array dq. Okay, this is done. Now after that, run one loop. Now we have to check the collisions, right? For int I is equal to 0, I is less than n, I plus plus. Okay, and here now see merged is int type now. So here for r I am using 82 SKI value. Okay, I'm storing the SKI value. For r I'm storing 82, and for l I'm storing 76. Okay, so now this is done. Now here first thing that I am going to write, I'm going to check if my stack is empty, or merged of I of 2. Okay, so 0 is position, this is else, and this is direction. So if this value is equal to r, so now you are going to say that merged I of 2 is an int, and here I am writing r. So actually in Java, when I am writing it like this, it is going to compare the value with the SKI value. Okay, so in Java it is possible to match this SKI value with this actual value. Okay, so this is possible. So this is going to give me the result. Okay, so there is no issue. Now after that, we have to just push this value into my stack. So see, I am adding position, health, direction, and original index. Okay, I am pushing all these values in my stack. Okay, this is done. Now in the else part, here in the else part, I am going to check if my stack is not empty, and then I am going to check if the peak of my stack is equal to r, and then I am going to check if the stack dot peak. Okay, stack dot peak, here I am checking the direction now, so here I am going to write 2. Okay, so if this value is less than my merged of I and 1. Okay, so what I'm doing here, see, I'm just checking the health. Okay, so if the health of this element is smaller than the new element, okay, at this particular value, okay, then I'm going to remove the topmost element from the stack now. Okay, this is what I'm going to do, right? So here stack dot pop. Okay, I have removed that element, and the value with the higher health, okay, I have to decrement it by 1. Okay, so here I'm going to decrease merged of I 1. Okay, health I have to decrease minus. Okay, this is done. Now here write one more if condition, and in this if condition just check if my stack is not empty. Okay, and stack dot peak of 2 is equal to r. Okay, just check for this thing. Okay, and now inside this I have to check if stack dot peak, okay, if the healths are matching. If the healths are matching, then in that case what I need to do, okay, if stack dot peak of 1 is health, right? Okay, here I should write 1. I am matching the health now. Okay, so if stack dot peak of 1 is equal to, okay, if both are matching, merged of I of 1, then in that case I have to simply pop again stack dot pop if both are matching, right? Then I don't have to decrease this merged I of 1. Okay, and in the else part I have to just write stack dot peak. Okay, stack dot peak element, and at this health, okay, I have to decrease the health of 1. Okay, stack dot peak of 1 minus. Okay, this is done. Here in the else part I have to just push the merged of I. Okay, that's it. Okay, now this is done. Okay, so see what I'm doing. Initially my stack is empty and the value is equal to r. I'm simply pushing that into my stack. in the else part I'm checking if my stack is not empty and stack.peak is equal to R. Okay, now in the else part I am adding for L partner, right? So here, then after that I'm comparing the health. Okay, so if the health is less than this one, then I have to remove that element, okay, from the stack top element, and for this one I have to decrement the health. Okay, and here in the if part I'm checking again if my stack is not empty and stack.peak value is equal to R, and then I'm checking if both values are matching. Okay, if health are matching, then I have to remove the values, right? I have to remove the values, so I have removed the values. Okay, this is done. Then after that, in the else part, if both are not matching, okay, if both are not matching, then in that case what I have to do, in that case from the peak element I have to take the health and reduce this. Okay, so this time simply means that the health of the topmost element of stack is greater than this merged of I1. That is why I'm decrementing it here. Okay, if it is less than, okay, see, if this is the part case, then I'm decrementing this. Okay, if both are matching, then I am removing this. Okay, but if the case is opposite to this, okay, then I have to do this one as well, right? Okay, so I hope that this is clear. Then in the end I have to collect the surviving robots health in the original order. So now this will come into effect of this thing. Okay, so now I'm going to write here, create one map, let's name it as surviving robots. Now iterate over all the stack one by one. So I'm going to create one robot array. Okay, so I'm going to use for each loop. Okay, so now in this case, this is my map. Okay, in this I am going to put the values, and now I am going to take my key as this index, robot of 3. Okay, so robot of 3 is going to be my index, and in this index I am going to put the value first of my health. Okay, so robot of 1. That's it. Okay, now in the end I have to give the answer in list format, right? So here after this, just create one list of integer array. Now iterate over all the elements one by one, and if now here I am going to check if my map contains the particular key. Okay, dot contains key at this particular index. Okay, then in that case I have to add this value in my result list, right? Dot get of I. Okay, that's it. And in the end I am going to just return the result. Okay, that's it. Now let's run the code and see if there are any code issues. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So for this problem my time complexity, see here O of n for this part, then I'm sorting, then O of n log n, then here again it is going to take O of n, okay, in this part. Okay, and here O of n, again O of n. So overall time complexity is going to be O of n log n. Okay, because of this we are doing the sorting step, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.